modelling is just breaking down questions. So we just want to break down a worded question into an equation or what it's actually asking us for. It's always going to ask us for things we know. So that's like our turning point, our intercepts. To sub something in or to graph it. So these are the things it's going to ask us to do. So here, this one's already given us an equation, this guy. So it's about the height of a ball that's been thrown at a speed of 10 meters per second. And that's the equation to tell us how high it is off the ground after a certain amount of time in seconds. So the first question here, how high is the object after 3 seconds? That is just a substitution question. We just want to know, well, when t equals 3, what does h equal? So we just sub our values in. Oop, that should be a 10. So we get 3 plus 30 minus 9, so 24. And when you have a worded question, you should have a worded answer. So therefore, 24 meters high, oh, can't spell, after 2 seconds. All right, next one. Using your calculator to assist drawing. Now, this is something that actually takes a bit of practice. So let's have a look. So let's go to our calculator and we're going to add a new page and call it graphs. So now it's super important that you remember to replace the little t's with x's, because if you try and use a different variable in there than what it's stated, it's not going to work. Alright, so our equation was, whoops, that was wrong, 3 plus 10 little t, so we're going to call it x, minus little t squared. Alright, enter. Now I can't see the graph very well, it's not all there, so I'm going to try and find some key points. And I'm also going to think about logically what values make sense. Well, to start with, I know that my y-axis is graphing my height. And my height, I don't care about it when it tries to go below the ground. That doesn't work. And I care about its maximum. So I need to find the maximum value this graph gets to so that I can tell it, well, I want to look at this view window. Then the other thing I need to think about is the time. Well, I don't really care about any time that's negative because that's before I threw it. So that doesn't make sense. And I don't care about any time after it hits the ground because nothing's happening then. It's just sitting on the ground. So one way to do this is we're going to go trace. Graph trace. So now, if I arrow across, I can see all sorts of different important features on this graph. I keep arrowing across. I'm going to get to the maximum. There we go. Tells me maximum. 528. So that's an important one to remember because our ball never gets higher than 28 meters. Next one that's important to remember is when it hits the ground. So that's what this one is, my 0. So I know that after 10.3 seconds, my ball hits the ground again. I don't care about any point after that either. So now I can change my view window so that it actually looks at the bit of the graph I want. So with x, that's my time. Don't care about before I threw it, so that's 0. Don't care about after 10.3 seconds, but I'm going to call it 11 seconds just because that seems easier. Alright, with my height, I don't care about any time after it hits the ground, so that's going to be my minimum. And if we remember, I think 28 meters was the highest it went, so we're going to go to 30 so we can see the top. And there we go. You can see the graph really well. So then you'd want to copy this graph down. You'd want to write down all your important points. So that's your x-intercept here, your turning point, which we found. You can also use trace to find your y-intercept as well, so that you've got all those values labelled when you graph your graph. On your piece of paper, you should also be graphing it. So usually we do y and x. For this one, you need to make sure your axes are h and t. So we'd want to graph that. 10.3, 528, and 3. So that you'd do a much better version than that with a ruler and such, but that's what we do. Determine the maximum height. If a question asks about a minimum or a maximum, it is just asking for the turning point. So you can find it on a graph, you can use your x equals negative b on 2a, you can use all sorts of things to find it. But for this one, we've already found it because we did our graph. So I know the highest height, max height, is 28 meters after 5 seconds. And then when does the object strike the ground again? Strike the ground, that is a 0. The ground is 0, so that is actually just asking for our x-intercept. We already found it, so that is hits the ground after 10.3 seconds. And so that's all it is. This one asks for the turning point, subbing in, intercept, and graph. Asks for everything. Okay, the last question was really nice because it gave us the equation. While this one also gives us the equation, it's actually asking us to show how that equation was found. These are the harder ones, but follow through, see if you can follow my logic. So we're trying to show the area of something, and it's a rectangle. So I know area equals length times width. So that's a good start. I can see that my question is only in terms of x. So I'm going to have to find both my length and my width in terms of x. Well, one of those is really easy because my width is just x. Done. Width of my space is x. But my length is in terms of y. So y equals L. Alright. So I'm going to have to figure out, can I write y in terms of x? Or what other information do I have? Reading the question, the other bit of information I have is this 30 meters. So I know this length of rope is 30 meters. So that means this one plus this one plus this one is 30. So 30 equals x plus y plus x. Okay, so 30 equals 2x plus y. Okay, well now we have an x and a y in an equation, so we can make it so y equals 30 minus 2x. Because y equals my length, so there we go. Now I have it. So then the last step is to actually find that area equation. So area equals 30 minus 2x times my width, which is x, which gets me back to the equation they started in the question. So I am good. I found it. What width will give the maximum area? Okay, maximum. There it's asking for my turning point. Okay, well I know I need to find x because that's going to be my width. So that's negative b on 2a. Alright, well for this one that's negative 30 on 2 times negative 2. So that's 30 on 4, which is 7.5 meters. So the width that will give the maximum area is 7.5 meters. Then generally they'll ask for the max area as well. Max area will then obviously equal 30 times 7.5 minus 2 times 7.5 squared, which equals 112.5 meters squared. So they're the sort of modelling questions you can get. There's some more to practice in your book.